How do I move things?
Hi there lads, Manuel here and welcome to my UE4 tutorial series. Let's say you need to move something, a ball, a car, a spaceship, or even a biomechanical nuclear toaster. Well, today we'll go through some of the main ways we can use to move stuff, their pros and their cons. Let's roll in. When we need to move an object, we usually have two different main categories of active movement we can apply. Through the use of physics, like using AddForce, or acting on the location of the object itself, like applying an offset, which can be world or local. The difference between the two, we'll discuss it later in the tutorial. Before starting, I'd like to show you how to set up the inputs, which we'll be able to use along this tutorial, and here we go. Okay, axis mapping is a constant input, which we can retrieve in any blueprint, and it can be done through the use of an event or directly getting the pure input. Well, action mapping is a one-time event and can be called when it's pressed and when it's released. So this is the main difference between the two. I already created a movement front axis mapping, and I assigned the W and S to it. Sorry. And okay, we are gonna create also the side movement. So side movement, and we're gonna set A and D, which respectively will be -1 and 1. What this means? This means that when we're pressing A, this side movement value will be -1. When we will pressing D, it will be 1. Same for W and S, with 1 and -1. So we can directly see them here saying movement front. And as you can see, we have an event and we have a value. When you put the event, this event will be called as it event tick at every frame and will provide us the value, the one we assign into the project settings. If we use the movement front value, we will just have like a simple value which we can use into calculation and everything. But since we already usually apply the movement over the event tick, I'd say that we should use this one, just to make everything like a bit easier and not like starting scattering everything around with multiple events. So let's start creating a new event, sorry, a new pawn, which we will call pp AddActorWorldOffset. Okay, as you can imagine, we will start with the AddActorWorldOffset function. So let's start with this. And I'd like to start adding like a simple cube, okay? And this cube can have, let's say, a spring arm and a camera attached to it. Okay, I'm gonna set the spring arm as a child of the cube, so it will be attached to the cube. And we can set the spring arm to 600 for the target arm length, which will extend the arm and make the camera further. And we can put something like 200 as a height. And we can simply rotate a bit the camera to watch our cube, and it should be good. We can test it immediately just to see how is the camera angle from the little preview here on the corner, and seems fine. So we can go on. So we usually manage the movement of our actor through the event tick. Why? Because it's an event which is getting called once every frame. So a game which is running at 60 FPS will have this event fired 60 times per second and all the relative functions which are connected to it. Where a game which is running at 30 FPS will have this event just called 30 times per second. And this is leading us to another problem, which is the frame independency. Because if we are applying an offset like 3, let's say, and we are doing it on a game which is running at 60 FPS, it means that this object at every frame is getting moved of 3 units. So a game which is running at higher FPS will result into having this actor moving way faster. And this is something we absolutely do not want, because we'll make stuff running different from PC to PC, okay? So What we want to do in these cases is taking always into account and into calculations the delta seconds, which is the difference of time between the last two frames. Okay, and we can also use world delta second, which is the same value, but is taking into account also the time dilation, so the slow motions or fast forwardings and this kind of stuff. We will speak about the frame dependency into another tutorial. This topic deserves a whole video on its own. So let's get back on our movement. We set 3 as a value. So if we go now into our actor here, into our pawn, he will move, pressing play, of 3 units over the x-axis per frame. And let's see. And he's moving fine. So why we are not using this camera? Because we didn't set the auto-possess player here, and we can just set it to player 0. This way, we will just possess the pawn, and as a consequence, having this camera as active one. So, okay, we want to be able to control the movement of our actor, okay, since we also just created the inputs into our project settings. So, let's write front movement and side movement. So those are our inputs values, okay? We can drag from here and say make vector. So this way we're going to create a vector with the value of x, which will be the movement front, and the y over the side movement. We can leave the z blank because we will need to fly, so we can leave it like this. What we want to do now is absolutely to normalize this vector, to get like a directional vector. So normalize, and this way we're gonna just get a simple direction, okay? Then we multiply it for a value which will be the amount of offset we want to apply at every tick, okay? So this value will be example 3, as we did before. So what is going on here? We are getting the inputs from the keyboard, okay? And we are making a vector out of it. We are normalizing to getting the direction we want to move, and then we are multiplying for the amount of offset we want to apply. So let's test it now. Forward, backward, left, and right. So everything is moving perfectly now. But what is happening here is that maybe it's not noticeable, so I'm gonna set these to 10 and press play. So is that our pawn is moving directly at full speed in whatever direction we are pressing. What we want to do is to make it smoother. So let's go back, let's drag out from here, and let's press promote to variable. Let's call it max offset. There we go. So creating a variable to define the speed will allow us to change these way easier and to expose it. So when we expose it and compile, we can move back to the scene here, to the viewport, and as you can see, the max offset value appeared here on the right panel. So we can change the value here, sliding, or just typing in the speed we want, like 5, and we'll be moving at 5, or like saying 50, and we'll be moving way faster. Okay, so let's put it back to 5. And let's move on with our smoothing. So let's move this a bit, creating space, and let's press here with the right mouse button and the type v interp 2. There we go. So what the vector interpolation does is transition a value to another based on delta time and interpolation speed. So the current is the actual starting point, the vector which we are starting from. The target is the value we are trying to reach, and in this case will be the value we are outputting here. The delta time will be needed because, as we spoke before about the frame independency, we need to make calculations based also on the frame rate. Because if the frame rate is changing, we risk to mess up this calculation. So from this, we just drag out and do delta seconds. There we go. And interpolation speed is just defining the speed at which this transition is happening. So let's do 1 for now. So now we end up with current. Current, we can create a new vector, which we call actual offset. And what this function is doing now is getting the actual offset, and frame by frame is trying to transition this value to this one. But this cannot happen until we also set the actual offset we just changed. So set actual offset, and there we go. So we connect it back to the event tick and to the AddActorWorldOffset. There we go. So what we need to do now at last is setting the delta location using the actual offset. This thing can be also done dragging out the actual offset from here, holding Control, and placing the get value. So what we want to do now is testing our function, and there we go. We're smoothly moving to the value we just defined. Left, right. Perfect. So now we know that the data location is the amount of offset the actor is getting moved every time this function is getting called. But what are teleport and sweep? Well, teleport is an option that, when it's enabled, is allowing our actor to not lose the physical state when moved, when offsetted. So in case example, our actor is falling down because of gravity, and we are moving it of 100 units on its side, it will not lose the fall speed. Okay? Then what sweep is a function that, when enabled, allow us to receive data about the eventual hit or overlaps of our actor. But we absolutely need to make sure that, since we are moving the actor, the component which will be the one offsetted and which will sweep will be the root one. So in this case, we need to have the cube as a root component. So in this case, if we get the hit result, we just go for a branch and we connect the blocking hit. Then we can just print something like collided. There we go. So now we absolutely need to put some obstacle. There we go. And now if we play, we should be able to hit and receive the collided print we just set. Okay, another effect of this sweep is the fact that the actor is actually stopping as soon as something is hit. So remember, absolutely, to make this work with the AddActorWorldOffset, the component which will be the one detected for the sweep is the root. At my time, I struggled so much on this, and the only thing I had to was just reading the description of the function. So make sure to set the component with collisions you need as a root. So moving forward, we are now moving to the AddActorLocalOffset function, and I created a new poem for you with a beautiful car, as you can see. Seemed like a bit the Flintstones one, but no worries, we'll be working anyway. So, since we are using the AddActorLocalOffset, and in this case we are doing a simple car, so we will just want it to move over its own x-axis, so forward and backward, and steering. So we can just use the x value in this case. So here I did the same thing we did before, but before we did it with a vector. Here we did the same thing, but with a float. And this interpolation function is available for rotators, vectors, and floats. So we are getting the actual acceleration. We are using a target, which is the front movement input we define in the project settings, multiplied by 15. And here, world delta seconds, and interpolation speed at 2. So this, as before, the speed at which the interpolation is happening. And as a result, we are setting again the actual acceleration. So frame by frame, the actual acceleration is changing and is reaching the target, which is 15, because 1 multiplied by 15. If we are pressing W, It's minus 15 if we are pressing S, and it's 0 if we are not pressing any of those buttons. Then I set the swap active, and I put a branch as we did before with a boom print in case we smash into something. In case we are not smashing, I'm actually doing a steering function, okay? So I'm doing AddActorLocalOffset in this case, and assigning the actual rotation to the Z value. The same function of before, with the value as a target, which is 2 multiplied for the side movement input. And this way we are setting the rotation of a smooth rotation to our actor. So let's try it out. As you can see, we can like move around and we can reverse smashing into something, and we will get the boom print on the top left corner. If we are smashing into the cube, we are not able anymore to steer, so we need to reverse back and move again. So everything is perfect. It's now time to move over physics. Here stuff will get a bit more complicated. Okay, I already created a cube with a camera and a boom, and I place it into our scene. Alright, so let's go into our PP AddForce pawn. What we want to do immediately is to enable the physics. So we go here under the physics tab and we press simulate physics. There we go. We compile, we move here, same thing, auto process, player 0, and we play. And we just play fall down. Perfect. So now we know our pawn is working and the physics is enabled. We go back into our AddForce, and another thing we want to do is to disable the everything of the pitch, yaw, and roll. So this way we're not gonna, our SpringArm will keep the same orientation. So if our cube is this way, as you can see, the SpringArm is maintaining the position. So it falls, but we are not rotating with the camera. In case this was enabled, I can show you what is gonna happen is that we are gonna follow the cube like this. And in this case, it's something we don't want, because we will also want to be able to rotate the camera around our pawn. So, disabling, 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 and I'm gonna remove the begin play and the overlap. Here we are. So, let's start AddForce. What we want to do now, we can go over AddForce at location, and not like just the AddForce normally, so we can have something more to speak about. Here we are. So target is cube, because we are applying the force to the cube, and this force obviously defines the amount of force and the direction of the force we are applying at the cube. This location is defining the point, the precise point where the force is getting applied. In case we would use just the AddForce function, this will apply a uniform force to the object, okay? So in this case, let's say we are gonna apply a force of 90,000 over the x-axis, and to make stuff easier, so let's just play like this. Oh, oops. So what happened here is that we applied the force to the position 0, 0, 0 in the map. And since it is way far from the center of mass of our cube, so position 0 is around like this place on the map. And since we are applying the force to a place which is like so far from the center of the mass, our cube is rotating way faster. So the force which result by this is way higher than the one we are actually applying. So let's say back our 90,000. There we go. And let's say get actor location. So this way should be a bit less traumatic for our cube. Poor boy. There we go. And play. Okay, our force is not enough to move. Okay, so what are we doing now is deciding that we want to apply the force for the same principle of which was like flying away the cube before, not here on the center, but a bit higher. So we'll make everything easier to rotate, like we are pushing the top of the cube. Okay, so what we do is just getting the actor location and we add a new vector which will have 0 on the x and on the y, so no side offset, but we'll apply the 50 centimeters, 50 units above the point of the actor location. So let's try now. And our cube is starting moving over the x-axis. Okay, it's moving a bit on the side because of the way it's bouncing, but the force is actually pushing the cube this way. Okay, a small thing I want to add before going over the input management is allowing us to rotate our camera around the object. So let's get the SpringArm, which is obviously the camera arm which is holding it, and we do add relative rotation. There we go. So since our SpringArm is not anymore inheriting the rotations, this will allow our SpringArm to rotate around the object whatever is the rotation of the cube. So let's say that we are adding 3 units, maybe it's too much, let's say one unit, because it's over tick, so every tick is adding 1. I think it's too much anyway. That one, okay. Let's adding over the relative rotation of the SpringArm 0.1 unit at every tick. And there we go. So we can accelerate a bit more, do like 1 or -1 and see. Perfect, so the camera is not flipping around the cube. So what we want to do now is being able to control it with a mouse. So let's break down doing split struct spin, or dragging out doing make rotator, which we can find here. There we go. And we want to apply to the Z, so the yaw. Let's drag it out and do mouse X. Mouse events? No, mouse values X. So now what is gonna happen is that moving the mouse on the X, so left and right, it's gonna return a value of 1 and -1. So we will be able to control the camera left and right, just moving the mouse like this. So now we have a point on this. We want to be able to control the movement of our cube, but if we just add the controls over these, what is going to happen is that we are going to have maybe the camera rotated this way, but pressing W, the cube will continue to go in this direction. So we want to be able to control the movement, and we want it to be related to the camera rotation. And how we do this? So let's go for this. So to be able to control the cube movement based on the camera direction, so the SpringArm, what we need to do is make a bit of space here because we will need it. And now we can take the SpringArm reference, get relative rotation, and from this one we are finally able to retrieve the forward vector, which is a vector which is pointing in the direction of the positive x-axis of the SpringArm. So in this case we'll be pointing in this direction, and whatever is the direction the camera is pointing, we will have as a forward vector this direction. Okay, so let me move it back. And we will also need the right vector, which is pointing on the y positive. Okay, so on the side. With these two and our inputs, we will be finally able to retrieve the values based on our input, simply. So multiply for float, front movement. This one will return us a vector which is positive, and we'll get like the positive direction in case we press W. Will be negative direction, so backward, in case we press S, and will be 0 as a product if we do not press nor W or S. So there we go. And same we're gonna do multiply float side movement. There we go. So what we need to do now is getting a direction from them. So we do add vector, and we add both of them together normalizing them because we want to get that direction. And finally now we can multiply these for the value which represent the force we want to apply. There we go. And we plug it here. Good boy. So now we can test it out. I'm facing this way, pressing W, and it's rolling in the right direction. Facing this way, W. Perfect. So we go left and right. Perfect. So now we can do just a little like turn around of this center cube. So what we did today is learning how to manage the offset, both local and world, and the AddForce functions. So I hope it was fun, I hope it was interesting for all of you, and we are gonna see you in the next tutorial for more advanced movement techniques. Thank you for watching. If you found any of this useful, make sure to smash the like button and to let me know what you think in the comment section below. If you want more UE4 tutorial videos, hit subscribe and catch up next time.